All right, how's everybody doing? Good? reInvent Day 2, how's it going so far? Thumbs up? All right. Thanks for being here today for our deep dive on Amazon S3 and Glacier. We've got a special guest as well, so raise your hand. This one is an easy one, a layup, but if you're an S3 or a Glacier user, raise your hand. I thought so, about 80% of you, so thank you. For being here, and thank you for being a customer of ours. My name is Craig Cotton. I'm the Director of Product Management for Amazon S3. I'm going to talk to you a little bit about S3 architecture, and then I'm going to turn it over to Henry, who's going to talk about Glacier. And then we have a special guest, Jamal Mazer from Sprinklr, an innovative social media company, and they're going to talk about how they're using EC2, EBS, S3, doing cross-region replications. It's got some pretty interesting things to talk about there as well. And then we're going to take some, if we finish on time, we'll take some questions with the mics here at the end, so keep track of your questions. And then, of course, after the session, we'll be up front here if you're embarrassed to ask it in the live audience, or if you don't get to your question, just let us know. So here is the agenda. I already gave you a little bit of a deep dive on S3, talk about Glacier, and then we'll hear from Jamal from Sprinklr. And here is the AWS Storage Portfolio. So we've got block, of course, with EBS and our EC2 instance storage. File would be EFS, our Elastic File Service. And then on the object side, we've got S3 and Glacier for your object storage. And then, of course, we've got a whole host of ways to get data into and out of S3 and Glacier and our other storage products. So just a flyby there. And make sure that you memorize the little product logos. There'll be a quiz on those later, so that some of the benefits before we get into the deeper dive. So, of course, S3 and Glacier are very durable, very highly available. We're going to talk a little bit about how we achieve that today. And, of course, very scalable, hopefully nice and elastic for you. We're going to talk a bit about security and compliance for each and some of the things that we're doing there. We think, the industry's broadest way to analyze the data in place. Many of our customers building data lakes on S3 and Glacier as well, and to be able to query it using various query tools. So we'll talk about that and some of the other uses for it. There have been sessions, hopefully you caught one yesterday afternoon, on the management of data within S3. Susan and Sundar and Alert Logic presented at that one. That was interesting. And then the broadest ecosystem of partners that claim API compatibility, something more than 100 customers that say they're some level of S3 API compatible. So really broad applicability across the industry there for you. So a bit more on S3 specifically. Some people think it was the first AWS service. It was actually the second, but one of the first three services. So we've been around more than 11 and a half years and got a lot of experience operating, building, and maintaining the service over that period of time. We operate within 44 availability zones, or AZs, and I'm going to talk a bit more about how that works. I think that's coming up in 2 slides. And we've got a lot more coming. These have already previously been announced, but 16 of those in 2018. And we're in all 16 of AWS's regions, and we'll be in all 5 of the new regions that are coming between now and the end of 2018 as well. We have our 11 nines of durability. So the likelihood that you write or put an object into S3 and that we are going to lose your object is not 0, but it's not very high. And we'll talk about how we achieve that durability as well. It's very high performance. We get millions of requests per second, and we've got trillions of objects stored in S3, so it's quite scalable. And we'll talk a bit about how you can get maximized performance out of S3 as well. High-level architecture for you. You've got your, you guys on the left there, and you've got your request plane where you're doing your puts, your gets, your deletes, and things like that coming in. And they hit a large fleet of S3 load balancers. Those load balancers then parse out the requests to our API servers through secured connections. And then fundamentally, we store blobs of your objects into blobs on the blob storage. And then we've got our index, or our metadata storage, which is a key value pair that tells us where your objects are located. So that's about the extent of the detail that we'll go into in the high-level architecture there. Let's talk a bit about availability zones. This is still very differentiated for S3 and for Glacier and for AWS. So when you write data to S3, we are always storing it in a minimum of 3 availability zones. And I say a minimum of 3 because some of our larger regions have more than 3 availability zones. Each of those availability zones, and some of you, anybody go to James Hamilton's Tuesday night session last year? Anybody? A couple of you. So he went into some of the detail on the network and the high-speed networking. So Peter DeSantis, I think, is having a session along those lines. I believe that's tonight. I don't know the exact time. But if you're interested in some of the broader details on how AWS is built, you might want to check out Peter's session tonight. For us, an availability zone could be a single data center, or it could be as many as 8 physical separate data centers made up within one availability zone. And those are connected via a private Amazon network, AWS network, that's made up of private fiber and very high-speed networking gear, and generally a very low latency network between those. And again, we store in a minimum of 3 AZs. So we can lose an entire availability zone, and you would likely not even know that that happened with the way that we store data. So it's a little bit different than some of the other folks out there in the world that store data in a single, they might call it a region, they might call it a zone or something like that, but it's generally a single data center, or what would be analogous to a single one of our availability zones. And that's one of the ways that we're quite different, we think, than a lot of the other folks out there. You're probably familiar with our storage classes. I'll do a quick flyby on this, but we've got S3 Standard. That's what came out 11.5 years ago. About 2 years ago, we introduced Standard Infrequent Access. So if you've got data that you're not going to access as much, you can save approximately 40% on the storage cost. There are a couple of trade-offs with a minimum object size and a minimum retention period and a retrieval fee, but for a lot of customers, it's quite cost-effective to use Standard Infrequent Access. And then for your coldest archive data, you might want to send that off to Glacier as your lowest cost tier. The difference is, of course, with Standard and Standard Infrequent Access, you'll probably not notice very much or any performance difference between those 2 storage classes, and that's millisecond retrieval. And that's synchronous, of course, whereas Glacier is going to be asynchronous access. And Henry will talk about the various retrieval methods, but we've got a few of them there for you. And you can see the pricing starting at about 2.1 cents per gig and going down from there dependent on the storage class. So a bit of a flyby there. And then, of course, we've got lifecycle transition. So I'm assuming a lot of you are doing a policy of, say, 30 days in Standard and then 60 days in Standard and Frequent Access, and then data that you can store in Glacier, moving that off to Glacier after your policy hits. I won't go through all of these. There are security sessions this week. There's a security workshop. I think that's a 2.5-hour workshop. So hopefully, I'm assuming some of you are involved in that. But security is job 1 for us. We're continuing to build and release more and more capabilities. A couple of the new ones I'll talk about on here today, but I won't have time to talk about all of these things here today. But we take this very, very seriously, and if you entrust your data to us, we want to make sure that it's secure, that we make it easy for you to achieve whatever kind of compliance that you need, and we always encourage encryption at rest in all cases. So a couple new things on the security side. In August, we released Amazon Macie. So that's a security classification and monitoring service that for now sits on top of S3, and that can look for various types of data and classify things that are PII, personally identifiable information, and can alert you if you've got buckets with open permissions, or alert you when PII data might be exposed to the public. So if you haven't checked out Amazon Macie, take a look at that. And again, that came out in August of this year. And then for those that are concerned about S3 data becoming available via the public internet, the first thing is don't make it public. That might sound... But these objects are born, they come out of the womb with no public access, so somebody's got to kind of turn that on. But we want to make it easier for you as well. So we had a security launch on November 6th, just a few weeks ago, and we launched in our S3 console. Now we've added a column that says access, and we'll show you a bright orange bubble that says public for any of your buckets that have public access, okay? And then you can click on that, and it'll show you the source of that public access, whether it's an ACL or a bucket level policy, and allow you to change that if that's not your intended consequence. Also remember that I can have a bucket with no public access, and I can have an ACL on an object that still has public access, right? So a lot of customers love that flexibility, and others, would prefer that it's no access is no access. So we've gotten some requests for that for the future. We'll try to figure out how to make that easier as well. But we want to make it easier for you to do these things. You can also see these types of things if you're a support customer using our Trusted Advisor service. We'll also do these bucket checks, and we'll proactively notify you for those as well. We also wanted to make it easier to encrypt objects. So a lot of customers have an encryption requirement. And previously, if objects came in without encryption headers, I had to block those and perhaps not receive and store the data that I wanted to store. So we've introduced default encryption on a bucket. So if you send objects to us that have an encryption header, we're just going to pay attention to that header and do whatever you tell us to do with it. If objects come in with no encryption header, then you're going to select server-side encryption with S3 managed keys for encryption at rest, or you can select SSE KMS, or key management service, for access level encryption, and we will automatically encrypt those objects for you. There's no charge for these features, any of these that I've mentioned. And then lastly, if you're an inventory customer, an S3 inventory report customer, we've added a couple of things there. On the security side, we're giving you the encryption status and the encryption mode of the objects in your inventory report, and that allows customers to more easily build compliance reports around that. We're also allowing customers that want to use big data tools like Hive-based tools or AWS tools like Amazon Redshift Spectrum or Amazon Athena. The preferred method to query inventory reports is generally ORC format. So you can now select ORC in addition to CSV file formats. Cross-region replication, we continue to invest in that. And this is where a lot of customers are happy with the way that we replicate, where I talked about via the AZs before, where we're going to store in a minimum of 3 AZs and protect your data that way. Other customers have compliance requirements or business requirements where they want to store data X number of miles away. And if the X is 100 miles or something like that, our AZs are miles apart, but generally speaking, not hundreds of miles apart. So I've got the ability to, on an object level, on a prefix level, or on a bucket level, replicate data to another AWS region. We allow you to pick any region on the globe that you like, so we give you the flexibility to do that. And we've added a couple new capabilities there. One is the ability, KMS has generally been a regional-based service, so we've added KMS support so that we can basically copy the KMS key from one region to another region, allowing you to extend cross-region replication to KMS encrypted objects. And then the second thing that we added in November, on the November 6th launch, was ownership overwrite. So if you are concerned about accidental or malicious deletions of data, you can cross-region replicate objects to another region, and you can change the ownership of that object to a different owner, thereby making it difficult or impossible for somebody to delete objects in 2 separate regions. So, and also very easy to set up from the S3 console for that. Customers use cross-region replication in many ways. Some might just do S3 standard. Very typical would be S3 standard in one region, and then I'm intending to not access the data in my secondary region, so you might do standard infrequent access there. And then, of course, a lot of customers will send it to another region and just lifecycle policy that off to Glacier to have a copy of it in Glacier in another region. So lots of flexibility and choices between here, the method that you choose, as well as being able to pick exactly which region that you want to send it to. Doing more with your data, so increasingly we're seeing customers build data lakes based on S3, so we'll continue to build more and more analytics tools to make it easier to analyze the data that's sitting in there. And you could already use things like Amazon Athena, Amazon Redshift Spectrum, EMR. QuickSight has a native now built-in analysis to analyze the data in your S3 buckets, as well as all of the third-party analytics providers that can also query data in S3. We're seeing a lot of increase in IoT storage coming out of the AWS IoT platform, Greengrass storage, other sensor data that's being stored in S3. Some of that is coming through Kinesis Firehose or Kinesis Streams into S3 as the storage location for that, as well as the predominant choice for storage for your AI and machine learning. So these are the things that you want to build models on and train over time. And generally speaking, the more data that you have for these things and the more data that you can train on, the better your AI models are going to be. So we're seeing a lot of uptick and increase in ML and AI storage in S3 as well. Last thing I want to talk about before I hand off to Henry is performance maximization. So has anybody heard that you need a 3-digit or a 4-digit hash in your object names to create some randomness? So a couple people are saying, yeah, I know what you're talking about. So for most of you out there, not all of you, but for most of you, you don't have to worry about that anymore. I'm not going to tell you exactly who should and who shouldn't, but generally speaking, we've done a lot of changes behind the scenes. First of all, we've increased our transaction processing from about 100 per second to 1,000. And a lot of people say, well, you said you handle millions of transactions. So the 1,000 per second is per what we call partition. So a partition is an internal term. That can be a bucket, can be a partition, or each of your prefixes in a bucket can be a partition, or we can further partition your prefixes into 100 different partitions. And each partition can handle 1,000 transactions per second. So we get scale by going horizontal on S3 and parallelizing a lot of the activities and actions. So in addition to having about an order of magnitude performance improvement in our partitioning, we've also automated all of that partitioning behind the scenes. So most of you don't have to do anything. We're going to see increases in traffic within your buckets and within your prefixes, and we're going to automatically partition for you on the back end, and it's generally taking maybe about an hour. So if you're seeing a lot of increased traffic and you're seeing a little bit slower performance, and if it doesn't resolve itself in an hour, maybe an hour and a half, then you might want to open a ticket. But generally speaking, you won't have to do anything to do that. And then for any of you, if you're, I don't know, a game producer or something like that, and you've got a new game launching, and you don't want to wait an hour or two for us to automatically partition to improve your performance, you can always open a ticket. Ideally, you give us a week's notice, but a few days would be good. Tell us about the bucket, tell us about your partitions, tell us what day and time your launch is, and we can pre-partition your buckets for you ahead of kind of a step function kind of an event like a launch. So keep that in mind. So generally speaking, most customers shouldn't need to deal with this anymore. If you want to be ultra safe, the best practice has always been introducing a random 3-digit or 4-digit hash, a character earlier on in your key naming. But again, just to be clear, if you don't do that, we have the ability to automatically partition no matter what your naming structure is anymore. That wasn't really the case 2 years ago, but that is the case now. And I'll show you what that looks like on the next slide. So again, here is if you did want to do a hash, again, the earlier in the naming structure, the better. And this gives us the ability to, if you have a 4-digit hash, I think that's 10,000. So we could have 10,000 partitions just on that one naming structure times 1,000 transactions per second each. And if you need more scalability than that, see me up front after the session. I'd love to talk to you, and we'll figure out what we need to do custom free. But that should handle 99.9% of you. So again, this will be automated. For most of you, shouldn't have to worry about it. If you do have the ability and want the best practices for performance, a simple 3 or 4-digit hash should do the trick. Okay, and again, we'll take questions in a moment, but when we're done, let me hand it over to Henry to give you a little bit of deep dive on Glacier infrastructure.
Good afternoon, everyone. Before I begin, how many of you use Glacier today? Okay, that's great. How many of you use Lifecycle to manage Glacier storage? Okay, great, thank you. So I want to share a couple of infrastructure insights into Glacier. So to start with, Glacier and S3 are very similar in a way that they are both object storage services on AWS. We both have 11 nines of durability. We leverage a lot of the platform's capabilities, for example, the networking, the cross AZ, replication, the infrastructure that's built for AWS Zones. But these are two very different storage systems I get a lot of questions from customers saying, hey, is S3 and Glacier are the same thing? Are they just like different, throughput characteristics? Are they the same? They're not. They're totally independent systems. And I have customers who use S3 and Glacier as two independent storage services to store their very, very critical data. For example, their encryption assets and things like that. And internally, we have certain product teams that use both services to back up their most critical data. So that's just something to give you context of how the services are different. The one thing that stands out from Glacier is it's an archive service. It's asynchronous, and we really try to drive down the cost. So Glacier starts at 0.4 cent per gigabyte per month. So even archiving a petabyte of data per month costs $4,000. And then we share a lot of the security compliance capabilities that S3 has, that the platform has. And we also work very diligently with ecosystem partners to ensure that tools that you're familiar with can connect to S3 and Glacier, use Lifecycle, for example, so that using AWS storage is very simple. So a lot of the customers that come to Glacier are tape customers. Let me do a show of hands. How many of you use tape today? How many of you have migrated from tape to Glacier? Great. I'm your fan. So this is really one of the things we've been working on to help customers. You know all of these, right? Like, tape is hard to manage. You have to roll the tapes every 5 to 7 years. It's really a hard job to maintain, like, the new tape formats. If you do it well, it's a given. If you don't do it well, you're looking at data loss or having some type of data format mismatch over time. So with Glacier, lots of customers really appreciate the fact that they don't have to roll their tapes anymore. They don't have to buy infrastructure. They also no longer have to manage the format obsolescence, the media obsolescence that they have to deal with tapes. Little clicker issue. So I want to dig in a little bit into the 11 nines of durability. A lot of customers tell me that this is a great number. It's a very large number, but it's different than how they think about durability on premises. So I work with a lot of media customers who store film assets, like the Hollywood studios, or digital preservation customers who store images of books and records for decades, right? So they are very, very peculiar about durability. And we told them about 11 nines of durability, and then they really want us to help them bridge a conversation between 11 nines and 2 or 3 copies on site. So we talked to a lot of customers. They typically store 2 copies of tape either in the same building or in 2 different buildings. This is actually a very large studio in Hollywood. It's probably not hard to guess whom. And they really wanted to know how we derived 11 nines. So we walked them through a Markov chain model that simulates failure, right? The simulation includes the failure rates, projected failure rates of storage devices for Glacier, the servers, the network components, the building, the entire rack and things like that, and as well as AZ. So we did all of that simulation, and then we came up with 11 nines. So what we asked the studio to do is look at their existing model, 2 copies of tape, and then give us a number of nines, right? So a couple weeks after, they told us that 2 copies of tape on the same site, they estimate that to be 4 nines of durability. And 2 copies of tape in 2 buildings, let's say both in LA, probably 20 miles apart, they estimated that to be 5 nines, right? That was an aha moment for them and for us, because it was the first time we managed to bridge 11 nines to a number of copies, right? And they realized that Glacier and S3 are both 7 orders of magnitude more durable than what they're used to buying, maintaining, and spending all of that time refreshing year over year, right? That was a really enlightening moment. And some of the things that customers really appreciate in the archiving space is this thing called fixity, right? Fixity means that the data is stored in the original format. It hasn't been changed. And it's a big deal for film studios, for archivists, if you're looking at decades of retention. Fixity is a really big deal. So Glacier and S3 do perform fixity check on your behalf in the background at no extra cost. right? So from an infrastructure perspective, we manage billions, hundreds of billions of objects in Glacier, and then we typically perform this fixity check for everyone's data a few times a year, right? So that is a number that is much higher than most customers who manage, let's say, 10, 20 petabytes or higher, right? Why is that? If they do that, if they store that data on tapes, the customers typically do not have enough drive to read all of their tape libraries once every year. They just have enough drives to support the occasional retrievals, but doing a full-scale 100% fixity check, pulling back everything, is not something that most customers can handle, right? So put that into context. I've talked to customers who pull back about 1% of their data per month for fixity checking, and they prioritize based on what is most important, right? So if you look at using Glacier, then we do 100% of your data for fixity checking a few times a year. And if we find any potential risk of data corruption, we will use an automatic recovery method to fix it up. So it's all done for you. It's all transparent, and there's no extra cost. So again, comparing Glacier to tape, which is what a lot of customers do, Glacier now has 3 retrieval options, right? We started with the standard retrieval option in the middle. It gives you data back in about 4 hours. And then last year, we added an expedited retrieval option, which returns data in 1 to 5 minutes. And then we also added a bulk retrieval option, which enables customers to pull back petabytes of data in 5 to 12 hours. So you look across the entire spectrum, now customers are able to replace any type of tape with Glacier. They weren't able to do that before we had expedited retrievals. They were able to replace tapes from offsite, from Iron Mountain with Glacier, but a lot of customers also have on-site tape libraries where retrieval times are in 20 to 30 minutes, right? Now, all of those can be moved to Glacier, and then you get a much better experience with no overhead of management. So that's really exciting, and we've been busy in the last year helping a lot of customers migrate their tape libraries into Glacier and moving these workloads. So I want to talk a little bit about accessing Glacier and S3. So Craig already mentioned that one of the preferred ways, or the most popular way of using Glacier and S3 is through the lifecycle management policies. It's really where customers use all types of the storage portfolio in tandem, and it follows naturally because your data typically goes from very hot to warm and to cold, right? But in addition, you can also use Glacier with its APIs. A lot of customers who are more used to having devices managing storage in the cloud, they use gateways. They can use third-party gateways, or they can use the AWS Storage Gateway, which runs in a virtual environment. And then there are a number of third-party tools. So I'll quickly go over the Glacier Direct Access. When you upload data, it's very similar to uploading data to S3, except that we throw away the file name you give us, and then we create a system-generated archive ID that is unique, right? So we give you that ID when the data is stored durably, and many customers take that ID and then put it in the database where they will match the local file name to the archive ID, right? This is, in the archive space, this is called a content address. It's a unique hash of your content. And if you upload the same file twice to Glacier, you will get 2 different archive IDs. So Glacier is inherently not mutable, right? Cannot be overwritten. And then on the retrieval path, you tell us the archive ID. You specify the retrieval option, expedited, standard, or bulk, and then we give that data back to you. Simple as that. So a lot of customers also prefer to use Glacier using third-party tools. They don't want to write code, which is totally fine. So we typically help them evaluate third-party tools in these 3 categories. If you're looking at small amounts of backup, then the consumer-grade tools will be helpful, like Cloudberry, for example, starts at under $50 per instance, and then you can deploy many instances to to your business or use it for personal cases. And then we have small, medium business use cases. They typically use like a Synology, like a Veeam, a QNAP. Some of those are small NAS, entry-level NAS devices that have integration with S3 and Glacier. And then many customers deploy a hub and spoke model where the satellite offices will each have for example, like a Synology, $1,000 device that captures 10 terabytes of data locally, and then the freshest data is cached, and the older data moves into Glacier. And then if you go into managing petabytes, tens of petabytes, you can look at enterprise-grade gateways or a number of the hierarchical storage management tools. So which one should you choose, or should your customers choose? It's pretty straightforward. We see most customers use S3 and Glacier in tandem with the lifecycle tools. It's super simple. This is where the S3 key, the live listing, the tagging capabilities are sufficient. And this is also where you do not need a super complex, comprehensive indexing system, right? You don't need a database. You're just using the S3 keys. For other customers who manage their own database, they may do some type of comprehensive indexing. They may do pre-processing of content like search capabilities. They would use Glacier directly, right? They will maintain the key to file mapping. And then last but not least, if you're looking at third-party tools, then you don't have to program. So last I want to share with you Vault Lock. How many folks know about Vault Lock? OK. So Vault Lock is a compliance storage capability that's available through Glacier. It's very similar, if not more easier to use than, for example, like an EMC Centera, NetApp, SnapLock. Those are the incumbent compliance storage appliances that you can buy on the market. So Vault Lock allows you to set compliance controls on your Glacier containers. You can do things like time-based retention, which is very popular. It's a requirement amongst US bank and broker-dealers. They have to keep transaction records for up to 7 years. A pharmaceutical company can also use Vault Lock to enforce multi-factor authentication on, for example, the most important formula. It governs all the records in the Glacier container, which is a vault. And then we provide an immutable policy and give you a two-step locking process. So if you have used compliance storage before, you must know worm storage, right? So this is basically non-override, non-erasable storage. So with Glacier, you can control time-based retention by telling us how long you want to retain the data with this archive agent days key control. And we also support legal holds. In case your archives need to go through a legal investigation, you can hold all of the assets independent of the underlying time-based retention. So for example, I have a record that's exiting the retention window tomorrow. Typically, I will be able to delete it. But if I put a legal hold on this container, then that particular record will be held indefinitely, right, until you remove the legal hold. So a lot of bank customers, including NASDAQ, are using Vault Lock. They find it super easy. You can basically get compliance storage for free without paying the overhead of a traditional system. So because we're talking about infrastructure, I want to share with you some of the interesting bits about Vault Lock that we haven't really talked about publicly before. Number one question is, I get a lot from bank customer is, does Vault Lock use worm drives, the non-mutable drives? Does anyone want to venture a guess? No, as in we don't? So we don't use worm drives, right? So we use the same media that we use to store Glacier data, but we implemented Vault Lock using the IAM policy platform, right? So we make the Vault Lock policy self-descriptive, and it can be extended as the IAM platform language grows, right? What we did is, Glacier started off being immutable storage, right? You cannot change something that you've uploaded to Glacier. Like I mentioned, you can upload the same file. You'll get two different IDs, archive IDs. Whereas with S3, you can upload to the same key, and it will override the object, right? That's the main differentiation. So how do we achieve worm? We start from the fact that Glacier is immutable storage, and then we layer on top of that a IAM policy that can be locked down, and it becomes immutable. So in the policy, we state that you cannot delete data from this vault for up to 7 years, and we make that policy immutable. So the third question I get is, what happens to vault lock data? Let's say it's retained for 7 years, but I close my account. Do I still have to pay for that, or what do you guys do with it? So if you close your account, we treat the vault lock data in the same way as if you had already deleted that. We will reclaim the storage area using our internal process, which is the NIST process for media sanitization, and we will remove your data according to our internal schedule. Right? So you don't have to pay for that, but what we recommend is if you decide to close your account, we give you a period of time up to 90 days to read that data, copy it to a different compliant storage platform before you fully close the account. Right? So that way you ensure compliance for yourselves. Right? It's your responsibility. The final question is, does AWS provide a designated third-party service? We don't, but we have a lot of partners that offer that. Designated third-party is an entity that always has read permissions to your regulatory records, just in case the regulated entity is not cooperative in a legal investigation. So we listen to customers, and then when we launched Vault Lock, we also worked with the industry leaders and produced a third-party assessment on how Vault Lock can be used to help customers achieve regulatory objectives such as SEC 17a-4. So this is available on the website. If you have any questions, feel free to let us know. So I'll give you one example of a one-year record retention. Right? Just how does it actually work? So for 1 year record retention, we translate that into a set of requirements, which is no one can perform the archive operation for archives that is younger than a year. Right? We translate that into an IAM policy, and then with about 15 lines of code, you have a self-descriptive policy that you can show your compliance officer, and then you can achieve compliance in a very, very simple manner. Right? And then you do this in the console, and then we'll show you that your vault has been locked with a retention policy, and then you're done. All right, with that said, I'd like to invite Jamal Mazar, our special guest today from Sprinklr, to share with us how they use AWS to build a disaster recovery service and improve customer experience. Thank you. Thank you.
Thank you, Henry. Good afternoon, everyone. So first, let me give you a little bit of context of what we do at Sprinklr, so you have a little bit better understanding. Sprinklr is the first unified customer experience management platform for the enterprise. We help some of the largest brands in the world, including Amazon, to do advertising, marketing, sales, research, commerce, care on Facebook, Twitter, LinkedIn, and 22 other social media channels globally, all on one integrated platform. Our customers can integrate Sprinklr with their legacy systems, like CRM, to get a unified system of engagement for their employees to work together across silos, real time, to manage customer experience at scale. This is a very high-level view of our architecture. The most important aspect is on the top right, where we are integrated with all the major social media channels. So we enable the users of our platform to engage and listen to their customers on any social media channel. We get data from all social media channels. These are mostly messages. We process those messages, enrich them, perform different analytics, if there's image recognition, sentiment analysis, and provide meaningful insights to our customers. Because we are integrated with all these major social media channels, we get large amount of data. we have petabytes of data, thousands of servers across different geo regions. And just to put things in perspective, from Twitter alone, we get a few 100 million tweets every day. So we are doing billions of transactions on a daily basis. This is a list of high-level technology that we are using. We are using several AWS services. We are using several open source technologies. Mainly, we are using Java on Linux. And then for automation and deployment and management, we use Jenkins, Ansible. And then on top of that, we have written a lot of custom code. We have written more than 1 million lines of code just to manage the infrastructure at scale. So the question is, what is the difference between high availability and disaster recovery? When you look at high availability, the way we define high availability is, it is the ability to run services across different zones in the same region, such that if one zone goes down, your service is still up and running without any interruption. The way we define disaster recovery is that you're running your application in a primary region, and if there's an act of God or any man-made disaster, for example, Hurricane Sandy, in that case, several data centers in New York City were flooded and were out for several days. So if you have that kind of disaster, you should be able to restore your application in a different geo region, which is at least separated by 250 miles. And that is what disaster recovery is all about. So in our case, when you're talking about disaster recovery, before I go there, the interesting thing to note is that S3 is already highly available. Other than S3, all the other services that we run, we make sure that we are running in a HA mode for our own internal services. If you look at disaster recovery, there are different approaches to disaster recovery, and there are pros and cons of those approaches. So the first one is what we call active passive, or also known as hot and cold. In that case, you run your infrastructure in one region, you make the copy of your data in a different region, and you keep that in sync, and when disaster happens, you restore using the archival data. The plus of this approach is that it's very cost efficient. The downside of this approach is that there is always a lag between the data in the primary region and the DR region, so whenever DR happens, you end up losing some data. So the second approach is hot and warm, which is active, passive. In this approach, you are running infrastructure in one region, then you are also running infrastructure in a different region, but the infrastructure in the other region is on standby. So it's in sync fully, and when disaster happens, you switch to their standby infrastructure. This approach works well because it does not, you don't lose much data. Then also you can switch very quickly. The downside of this approach is that you are running redundant infrastructure in two different regions, and it's cost prohibitive. The third approach is, which is hot and hot or active-active. In this approach, you are running your infrastructure instead of across zones. Similarly, you're running it across different geo regions, and both the infrastructure in different geo regions is active and taking and using customers. So in this case, if one region goes down, your application can work seamlessly because it's processing the requests from the other region. This is a great solution and an ideal solution. The challenge in implementing this kind of solution is that when you are implementing disaster recovery, your data centers are further apart in distance, so there is latency. And if you have very write-heavy application, it's very difficult to run them at a long distance. So in Sprinklr, for disaster recovery, there are two most important SLAs that we rely on, and that's what we commit to our customers. One is recovery point objective, which is RPO. Recovery point objective means that if the DR happens and you restore your application in a different region, how old is your data from when you're restoring it? We typically commit to 24 hours of RPO. The second thing is recovery time objective. In recovery time objective, the point here is that when you declare DR, from the time you declare DR to the time you restore your application, how long it takes you to bring everything back up. In our case, it varies from customers from 6 hours to 24 hours. Typically, when we are doing DR, we are aiming for 4 hours of RTO. We use 2 AWS regions. We use Virginia as our primary site, and we use Oregon as our disaster recovery site. And then we also use third-party, independent third-party to come and validate our DR test twice a year, where we do a full restoration to make sure everything works fine. In terms of scale and scope of our disaster recovery, we have thousands of EBS volumes for Mongo, Cassandra, Solar. Then we have 1,400 plus Elasticsearch servers. These are SSD servers, i3 4S, i3 8X large. And they are running hundreds of Elasticsearch clusters. We also have thousands of servers running 100 different services. And each of these services have unique configuration and code. So when you try to implement a disaster recovery solution at a high level, which we are doing using active-passive approach, there are 3 major challenges. First is ability to copy the data and configuration in the same region quickly. Then transferring it to a different region and trying to keep it in sync. And third, having the automation to be able to restore everything up quickly when the disaster happened in the disaster recovery region. So first, talk about the first challenge. When we started out, we try to copy the data in the same region quickly. And some of the challenges we run into is that the traditional backup approaches, because of our scale, didn't work very well for Mongo, Solar, and others. So you cannot take a dump and restore from the dump. We end up taking EBS snapshot for taking those backups. The second thing is that we also started, we have to implement our own status dashboard to show us the backup status for all the clusters that we have in the context of our application and platform to make sure that everything is in sync. Then we run into limits issues. First limit issue we run into is you have thousands of EBS snapshot volumes. You start running the snapshots, and you run into Amazon limits. So we worked with Amazon. They help increase the limit. And the second thing we end up doing was staggering our snapshot copying over the period, so we are not triggering all of them simultaneously at the same time. From the S3 perspective, one of the challenges that we run into is we use S3 for backing up our Elasticsearch cluster. In our Elasticsearch, we have 100 plus clusters, 1,400 plus servers. So we have more than 1 petabyte of primary data in Elasticsearch clusters. Keeping that data, when we start writing those 1,400 servers in parallel to S3, we ran into S3 I/O throttling limits. And these kind of limits, once we hit those limits, we work with AWS, and we come up with the proper partitioning scheme for our buckets, and also coming up with the proper naming convention for each of our clusters. So when we are doing the backups, we are using appropriate partitions. And that helps solve this problem. Then second challenge, when we start transferring the data from one region to another region, and from Virginia to Oregon, we run into how many concurrent incremental snapshots you can transfer from Virginia to Oregon simultaneously. So again, we work with AWS, so they increase the limit on how many parallel snapshots you can transfer. Then second issue was that there is not enough physical bandwidth. So they added additional bandwidth, and that helped. So what went well from day one, which was very impressive, was we have more than, I would say, 3 petabytes of data in S3 buckets. And we were keeping this data in sync from primary region to secondary region, and it worked like a charm from day one because we have good partitioning. In our use cases, basically everything that we write to S3, it gets copied pretty quickly in the other region, but S3 is eventually consistent, so if you have something which requires that it needs to be there in a certain time immediately, then you may want to look more closely to it. But for our use case, it was good enough, and we never saw any problem with this. Now, the third challenge, which is interesting, is that once we get the data in the other region, now you have to restore the entire platform. How do you do that? So there we realized that there is no way we can manually restore everything or have some instruction manual. So you have to write some automation, and it needs to be a single-click automation. So what we end up doing is, after several trial and error, we wrote automation to launch thousands of servers with all our dependencies for our platform, restore the data, create snapshots, from snapshots, create volumes, attach them to the servers, do the DNS entry updates, do the code deployments, or do all the configuration, all of that through just one click of automation. One of the interesting things that we learned during this process is, again, in restoration, is S3 ability to scale. Again, we have more than 1 petabyte of data which is sitting in S3 for just Elasticsearch. Now we launch 1,400 plus Elasticsearch servers. And we run, all of these servers go and read from S3 directly in parallel to restore this 1 petabyte of data. And once the data is restored in the server and they're running, the servers replicate the data across region for high availability. So you end up getting 2 petabytes of data in the running servers from 1 petabyte of primary data from S3. From the time to launch the servers to the time that everything is restored and replicated for Elasticsearch, it took 2 hours, which was pretty impressive, given we have more than 1 petabyte of primary data. Some of the challenges we run into, again, here in restoration also was we ran into some API limits where we were hitting limits as we were launching so many servers and calling many API calls. We worked with Amazon. Some limits were hard limits, so we end up implementing caching scheme to make sure that we are not making too many AWS calls for status and other things, and make sure that we are minimizing the number of calls we are doing during the restoration. The second thing that we run into was when you're launching thousands of servers and you're looking for a specific type of instance and you need hundreds of them, you may not get them. So how do you mitigate that? We end up implementing some intelligence in our restoration process for all services, and we have to design that to try to look for instances in the same family if we can use fewer bigger instances or more smaller instances. And if those were not available, then try to look for adjacent families. So for example, if I3 is not available, we can try I2. And that helped a lot because in some cases, sometimes you do hit some snags where there is not enough capacity, so you want to make sure that you have some mitigation plan for that. And then we also, one of the things that we did was we built a custom dashboard to provide the overall status. Because once you click the button to restore everything, then you want to see the status of how everything is going. It's a simple dashboard, but it shows you overview of it looks something like this. It shows you the overview of what is the status of the process, which failed, which succeeded, and anything that fails, we keep retrying till it works. So the key takeaways from this is we are keeping more than 4 petabytes of data in sync across 2 different geo-regions in AWS. And on a daily basis, to keep this data in sync, we are sending 50 terabytes of incremental data from one region to another region using S3 and EBS snapshots. The bandwidth limit increase that Amazon provided us, and then some of the concurrent snapshot optimization that we did, helped bring down our copy time from 36 hours to under 8 hours, and that helped us with our 24 hours RPO. The other thing we learned was that configuration metadata and code, especially configuration metadata, is very critical to make sure you have in sync and up to date. So configuration like your ELB configuration, your RDS configuration, your VPC configuration, we capture all those configuration daily and we put them in S3, and we sync that using S3 sync in the other region. And we use that as a part of the restoration process using our automation. And the most important thing was that we implemented one-click automation. It took us several trial and errors, and we did that, and we still spend a lot of time to make sure that it stays current because we are always doing some new work. But that single-click automation was critical for us because now when we are running the DR test, we literally go click a button, watch the status, and have everything, see everything come back up within hours. So that's all I have here. I will hand it over to Craig for some additional information.
Thank you, Jamal. Super interesting what Sprinklr is doing. Thanks for sharing the story. Just 2 more slides, and if you have questions, we'll have about 5 minutes for questions from the audience, and then again, we'll be available after the session. We want you to be aware of the other S3 and Glacier and storage sessions coming up, so I won't go through all of these, but you might want to jot down the STG number there. And of particular interest tomorrow at 11:30 is the Storage State of the Union. So Milan Thompson-Bukovic and Wayne Duso will talk about all the different storage products at AWS and what's going on there and have some product announcements. And then you can see some of the others there. And remember, these are all fully sold out, except we reserve 25% of the seats in every session. So you should be able to get into most of those if you get there a few minutes early. We've got some new storage training online. So if you go check out www.aws.training, and where we're going here is certifications that you can achieve, get testing for, put on your CVs, and things like that to achieve AWS certifications. So take a look at those. And with that, does anybody have any questions? Somebody does. Step right up. Don't be shy. All right, we've got a customer.
I was just curious, you mentioned the expedited retrieval from Glacier, 1 to 5 minutes, I think. Is there a data limit for how much you can request for expedited retrieval like that? Is there a size limit?
Yes, great question. So expedited is designed for urgent retrievals. We support up to 250 megabytes per request. So that is guaranteed to come back in 1 to 5 minutes. Okay. Anything larger than that, you can get up to 150 megabytes of combined throughput. Okay. Right.
Thanks.
Cool. Thank you.
Yeah,
any other questions?
I have another question about Glacier as well. I was wondering if it'd be possible to shed a little bit of light on how the archive metadata is stored for Glacier. The reason I ask is because one of the operations that it supports is retrieving a vault inventory to retrieve a list of the archives in your vaults and the metadata associated with them. But that's also an asynchronous operation that takes several hours to complete. Right. I'm wondering if it'd be possible to shed some light on how that works or the reason for this delay.
Great question. So there are 2 pieces to it. So the metadata of Glacier is really the hash, right, that we compute based on your content. It's stored in the same durable format as the storage. That is the hash we use to do checksum comparison in the background over time for fixity. Inventory is one place you can get this archive ID, and inventory is really meant for your local database that maps Glacier to local files is lost, and you have to recreate that. But typically, if you have a database that does a file mapping to the Glacier archive ID, then you're in good state. Beyond that, most customers store the metadata in their index, and then there's a Glacier archive description field up to 124 characters. You can store some metadata there.
Okay, we have time for one more question with the whole audience, and then the 3 of us will be up here for at least 10 or 15 minutes if anybody has other questions. So I think you are next. Go ahead.
Thank you. We all hear about 11.9s all the time, and you gave an example of calculating it based on Markov chains for movie vendor. Has that been, do you run analytics on the data to know that, or is that 11.9s a totally theoretical number?
Great question. It's not a totally theoretical number. That was our design objective, and our empirical data that actually shows we have higher than 11.9s.
It's for both S3 and Glacier.
Yes.
We're not going to tell you what we think the actual is, but it's at least 11.9s.
Yeah.
Very cool. Thanks.
Okay,
Thank you.
thanks everybody for attending. And again, if you have questions, just come see us up front and enjoy the rest of reInvent.
Thank you, guys.